All right, in the last video, we disproved some identities by plugging in some values and proving that it in fact doesn't hold true and it doesn't end up working the way that we had wanted it to. This time, we're going to do the same thing, and we're going to see that it in fact does hold true. So this right here is saying that if we take the square root of some product, like, I don't know, a squared times b squared, that we will get a times b, that you can distribute that across, and then it will eventually cancel out and become its normal old self. Let's plug in some numbers and see if that actually holds true. So in this case, let's have a be equal to 2, since that was what it was in our original example, and b, why not 3? Like, let's keep it simple. So this becomes the square root of 2 squared times 3 squared, and that should be equal to the product of 2 times 3. So 2 squared is 4, times 3 squared is 9, and 2 times 3 is 6. And then on the left side, 4 times 9 is, well, 36 equals 6. And we already know square root of 36 is 6, so 6 equals 6. Okay, cool. So this actually shows us that the logic seems to be holding true. And one thing that's worth knowing is that if you disprove an ID, you only need one example. To prove an identity, we actually need a lot more work than this. So it's not something that we're going to get into today in this unit. It is something we're going to get to in a little bit, but for now, just checking even once and seeing whether 2 random values plugged in give you what you're expecting, or if they prove your identity wrong, is a good way of checking your own work to see, has what I have done become something that makes sense? Oh man, the grammar there. Oof. Okay, you get the idea. Plug in some numbers, see if the logic actually holds, and if the logic holds, this is an identity that works.